Howdy, 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 and welcome back to Mr. Kosal's Geometry YouTube channel. Welcome back, everybody. Here we go again. Happy Friday, everybody. It's Friday. You know, you get the next couple days off doing nothing. Spend some good time doing whatever you want to do. So I want to start off with the answers for 10.2. Here they are. Check them. Check them. Hopefully you're all doing your homework. You guys are doing a great job emailing me and staying on top of your studies. Make sure I do get these assignments by midnight. I try to stay diligent through the day. I'll always shoot you back an email just saying, hey, I got your homework. Looks good. You know, some of you still need to continue to show your work. Answers are just not good enough, so please show your work throughout this whole homework process online. Also, legibility is a big thing with me. When you take pictures, make sure they're not blurry. If Mr. Kosal can't see it, then I can't check the answers, I can't grade it. You know, take some time, get some good pictures, and send them my way. But here are the answers. Here they are. Check them. Feel free to go back and redo them, and you know, we'll go from there. Moving on today. Section 10.3. Go ahead and get your notes out. Get your favorite pen, get your favorite pencil, get a piece of paper, and let's get rolling. 10.3. The notes are arcs and chords. Remember, chord is spelled with an H. It's not an extension cord, it's a chord. All right. Arcs and chords. How do we want to get started? Let's get started off with a theorem. There's a theorem that pretty much leads this entire lesson. Actually, no, there's two theorems. No, there's three theorems. Let's call this theorem number 1. 3 theorems today. I think I had 3 examples for you. Maybe 4. We'll make it short. We'll make it quick. Theorem number 1 pretty much says this. If you have a circle, give it a center. Let's call it center L. If you have 2 chords of equal length, so let's make some chords. Hopefully you remember what a chord is. Chord goes from an endpoint to another endpoint on a circle. That's an example of a chord. Let's label this chord. How about CD? And I need another chord. And I want to make the second chord equal length to chord CD. So let's put a point right here. Let's call it E. And I need to try to transfer this. I want to make it equal, so let's see if we can do this right. Okay, I'm happy with that. You know, hopefully everybody, if you're watching, these 2 chords look of equal length. Maybe this one's just slightly bigger, but we're going to say they're equal. We're going to say they're equal. Here's what the first theorem says. If you have 2 chords that are equal, if CD is equal or congruent to EF, here we'll set this up as an if-then. If chord CD is congruent to chord EF, if these 2 green chords are exactly the same on the same circle, then their arcs are the same. Meaning this arc from C to D has to be equal to this arc from E to F. Then arc CD has to be congruent to arc EF. And you could also go backwards on this one, folks. You could, let's get another one going. If arc CD is congruent to arc EF, once again, you could go backwards. You could start with the arcs. If these 2 yellow arcs are the same, then you are allowed to say that the chords are congruent. Chord CD is congruent to chord EF. That's the first theorem, folks. Pretty simple, pretty easy. EX1, example 1. All right. Circle A is congruent to circle B. We'll draw a picture in just a second. And arc WX is congruent to arc YZ. I'd like you to find WX. Okay? I'd like you to draw two congruent circles. Wow, that is just not a good picture. Feel free to laugh at Mr. Kosal's drawing. That's just a terrible circle. Either way, we're gonna work with it. We're gonna say these are two congruent circles. They're exactly the same, even though they don't look the same. We're gonna say that they are the same. This is gonna be circle A. That's gonna be circle B. I'd like you to draw a chord on circle A. So let's go. Did you make a sound when you made that chord? If not, I'm telling you, sounds make chords better, makes lines straighter. And let's make a chord over here with sound. Go ahead, come on. I'll bet you out of my 83 students, there's probably 2 of you that actually made a sound. Everybody else is awkwardly sitting and staring. Alright, we have 2 chords. We are going to say that these two... Oh my gosh, these 2 chords are not equal. These are arcs. Oh boy, oh boy, oh boy. Okay, hold on. Let's fix this. I almost said that these 2 arcs, I almost put the single tick mark here and here. I'm so focused on making sounds with my line segments and my arcs and my chords. I'm forgetting the math here. Alright, these yellow arcs are congruent. Okay. Let's do a double tick here. You could do single ticks, double ticks on the arcs, just like what we did up here with the single ticks on the chords. You could do the same thing here. Let's make a double tick here, double tick there. If the chords are the same, the arcs are the same. If the arcs are the same, the chords are the same. Alright, so these arcs are exactly the same. We need to find WX. We need to find this distance here. Now, I got a little more information for you. Here we go. This chord is 7x minus 2. So from W to X is 7x minus 2. And this chord over here from Y to Z is 5x plus 6. Alright, if you need an easy question, we got an easy question here for you. If these arcs are the same, that means that the chords are the same. Set them equal to each other, and let's solve for X. Easy. Subtract 5x on both sides. Add 2 on both sides. So if you need to see the work, show the work. Plus 2 plus 2. So I got 2x equals 8. Divide by 2 on both sides. Gives you a nice, neat, wonderful answer. X equals 4. Not done. Not done. We're not done. Do not move to the next problem. Do not flip the page yet. We need to find WX. So WX is... I don't know. Don't put 4 in there. Don't do that. WX. Okay, WX is from here to here. It's the expression 7x minus 2. So take this, plug it in right here. Mental math, folks. 7 times 4 is 28. And then 28 minus the 2 is going to give you 26. WX is 26. A couple of those questions in your homework. They should be pretty okay. Alright, that's the first theorem. We got 2 more to go. Let's get rolling. Feel free to pause. Feel free to go back and rewatch what I just showed you if it doesn't make sense. Theorem number 2. That is a 2. A sloppy 2. Theorem number 2. It involves a circle. Draw a circle. Give it a center. And more importantly, give it a diameter. Okay. While you're setting this up, I'm kind of looking over this. I don't want you to write the entire theorem in your notes. I want to give you the important stuff. So let me go ahead and read the theorem, and I'm going to draw on this circle as I see fit. If a diameter, here's what it says. Theorem 2. If a diameter or a radius, it could be a radius or diameter. If a diameter of a circle is perpendicular to a chord. Let's do this. I'd like you to draw a chord that's perpendicular to the diameter. So let's do this. So I got a chord. Let's call it X, Y. There's chord X, Y. If you have a diameter that's perpendicular to a chord making a right angle, then it bisects the chord and its arc. So let's put A over here. Let's put B right here. let's put Z as the intersection right there, and let's call this circle C. I don't know. I want to get you some vertices. Get you some letters going here. All right, here's what this theorem says. If, we'll set this up, then if diameter AB is perpendicular, is perp, to chord XY, which is basically what I just said again. If you have a diameter, AB, is perpendicular, right angle right here, folks. If it's perpendicular to this chord, then this is a two-part proof. Number one, and number two, very, very easy. Number one, it's going to bisect the chord. So, if you kind of take a look at this entire chord, that diameter right there, if it's perpendicular to that chord, it's going to cut it into two equal pieces. This piece is going to be the same as this piece. I'm going to put a little single tick mark there, single tick marks there. First one, XZ. So the distance from X to Z is going to be congruent from the distance from Y to Z. There's the first part. This is the two-part theorem. If a diameter is perpendicular to a chord, then it's going to cut the chord into two equal pieces, and it's going to cut the arc into two equal pieces. So if these two are the same, these two arcs are also going to be the same. Let's do a double arc, or double tick mark right there. Then arc XB is going to be congruent to arc YB. That's it. Nothing fancy. Not too shabby. Example 2. Chances are we're going to take this theorem and we're going to use it for example 2. So hopefully that just made a little bit of sense for you. Alright. Draw a circle. Give it a center. That center is G. And give it a radius going to the left. Alright, let me move this up a little bit. Circle G. Let's call this E, elephant. And I'd like you to make a chord going up and down, and more importantly, make it perpendicular. I need to get a new red pen. This is slowly dying, slowly dying. Make it perpendicular. Okay, we're going to call that intersection H. This point right here, we're going to call this daffodil, D, up there. Frankfurt, Germany. I don't know, I'm just thinking of the first word that comes with F and E and D. Alright, in circle G, the measure of arc DEF is 150 degrees. And DH, the distance from D to H, is 5. I'd like you to find, let's find two things. Let's find two things. Part A, Part B. This is the given information. They're going to tell you that the measure of arc DEF is 150 degrees. So D to E to F is 150 degrees. Man, I cannot see that. Let's write over this. That's 150 degrees. And DH is 5. Let's start off with an easy one, folks. I'd like you to find FD. Hopefully this is easy, folks. Hopefully this is easy. I'm asking you to find this distance from here to here. Well, go back to the last theorem. Read what it says. If you have a diameter or a radius, you know, you can have a radius as well. But if you have a radius that's perpendicular to a chord, which we do, radius, chord, perpendicular, then it's going to cut this into two equal pieces. If that's 5, folks, that's 5. And if you want to find this total distance, F to D, add those two together, you get 10. Next one, I'd like you to find the measure of arc EF. So find the measure of that arc. No, it's not 150 degrees. Shame on you. That's the measure of D to E to F, that yellow arc. Go back to the last theorem if you need to. This means that if you have it perpendicular to a chord, diameter perpendicular to a chord, these two arcs are going to be the same. These two have to be the same. Basically, take